Can you show us how to go to the stuff?
Go to the stuff.
From the website?
The videos? Yeah, I can show you at the end of the lesson. Okay, so as we were saying, guys, a neutron and a proton, we know both of those are much more massive. And when I say massive, they have a lot more mass than an electron. Now, as far as size, I mean, I don't know if an electron is bigger in size. We've never seen an electron. Okay, so but in terms of mass, though, that mass of an electron would suggest that it's probably smaller. Okay, so in terms of mass, one proton has a mass of 1.67 times 10 to the negative 24th grams. And that number, to me, at first when I look at it, it's kind of hard to put into thought how small that is. But, you know, the 1 gram weight, okay, a 1 gram weight, we're talking about like a fingernail clipping. Okay, that's you know, if we're talking about 1 gram, we're talking about something that small. Okay, in a 1 gram weight, okay, we would have 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000 protons. Okay, if it were made up of protons. Okay, that is not 1,000,000 plus, and I'm not talking about 4 million. I'm talking 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000 protons in a 1 gram weight, plus a few extras. Okay. So that's how incredibly small we're talking about when we're going protons. Okay, an electron is right around 2,000 times smaller. Okay, so now we're talking about 1,000,000 times 10 million times 1,000,000 times 1,000,000, but not 10 million times 1,000 in the end. 1,000,000 times 1,000,000 times 1,000,000 times 1,000,000 times 1,000. Okay, I mean, we're.
First question you told us about the nucleus contains the protons, neutrons, and the
Quarks.
So why does this one say the nucleus contains so much of the mass of the atom because of the protons and neutrons? Like in electrons.
The protons make up quarks make up protons. So if you have protons in the nucleus, therefore you have quarks in the nucleus because quarks make protons. Was that your question?
Are you sure, man?
Alright. To write out that number, guys, I was telling you about, it would be. Alright, that many. Okay? That's how many protons that'd be in a 1 gram weight if it was made out of protons. Okay? No, that's just. Okay. I mean, we left trillion behind a long time ago. I mean, we go 1,000, 100,000, 100 million, 100 billion, 100 trillion. I mean, we just keep going. Okay. So this is 3, 6, 9, 12, 15, 18, 24. No. 18. What am I? Whatever. There's probably more zeros than that. I'm just gonna stop there. Okay, it's a lot of zeros. That's what. That's 21. Well. There we go. 24. And then if I make that electrons, then we, Okay, so that's, and we're talking about here a 1 gram weight. Okay, so in terms of measuring the mass of an atom, do you think a gram is a very good measurement device? No. Okay, we don't use the gram to measure the mass of an atom. We use something called the atomic mass unit, or the AMU. Okay, and the atomic mass unit is going to be equal to the mass of 1 proton. Okay, so 1 AMU is the mass of a proton. So if I have 5 protons, I have 5 AMUs. If I have 10 neutrons, I have 10 AMUs. Because a proton and a neutron are about the same. Okay. So if I have 10 protons and 10 neutrons, how many AMUs do I have? 20. Okay. If I have 10 protons and 10 neutrons, then that would be an atomic mass of 20. Because both a proton and a neutron are atomic mass of 1. It's going to switch images real quick. It's going to come back though. Give me just a second, guys. Sorry. Okay. So, in terms of an atom, guys, the differentiating factor, okay, the thing that makes me determine whether I have oxygen or nitrogen, okay, the thing that makes those different is not the neutrons, it's not the electrons, it's always the protons. Okay, if I take a nitrogen atom and I add a proton to it, it's not nitrogen anymore. Now it's oxygen. Okay, so the difference between elements is the number of protons. If I change the number of neutrons, it does not change the element. It just changes the weight of it. If I change the number of electrons, it does not change the element. It just changes the charge. Okay?
Say it again, difference.
The difference between elements is the number of protons. Okay, if you notice up here, good looking at the periodic table, do you ever see the same number twice?
No.
Hydrogen has 1, helium has 2, lithium has 3, beryllium has 4. Changes every time. It's never going to be the same because you can't have two things with the same number of protons and then be different. Okay, I mean, they can't be different elements. They could have different characteristics, but they can't be different elements. Okay, so the number of protons is going to be governed by the atomic number. Okay, so the atomic number tells us the number of protons. Okay, so the atomic number, guys. If I have, looking at my periodic table, each element has a box up there. If I'm looking at carbon, up here we have a 6. Down here we're 12.01. Okay, the atomic number is the top right. And guys, what does that atomic number tell me? Number of protons. Okay, so looking at this one, carbon has how many protons? 6. How many protons does oxygen have? 8. How many protons does neon have? 10. How many protons does calcium have? 20. Easy, right? Look at the number. Whatever it is, that's what it is. Okay, so if it says 20, it's 20. Okay, so that's the atomic number. Okay, the second number that's displayed up on the periodic table is called the mass number. The mass number. And the mass number essentially tells me how much or how many AMUs, how much mass does the typical atom have. Okay, so looking up here at carbon, I have 12.011. The typical carbon atom has a mass of 12.011 AMUs. Okay, and the typical oxygen atom, the average atom has a mass of 15.9994.
Look up non-average atom.
What now?
It's a non-average atom.
What do you mean non-average?
You said the average atom has.
Okay, I mean I could have 15, I could have 16. Okay, we'll talk about what that means in just a little bit. But the average, if I take all of them and average them together, then the average would be 16. In the same way, I could take all the weights in the class. Everybody's weight. I mean, I'm 165. Somebody might be 120. Somebody might be 200. Somebody might be 198. Average those together and get the average weight of the class. Okay, but we're all people. Okay, in the same way, we're all people with different weights. Those will all be carbons with different weights. Okay, but we'll get there. Okay, so the atomic mass number is the one at the bottom. Okay, and that atomic mass number, guys, gives me the number of protons plus the number of neutrons. We said the atomic mass number represents the total mass of the atom. So when I'm talking about the number of protons plus the number of neutrons, why don't I include the electrons in there? Because what now? It's not just the mass of the nucleus. It technically does include the electrons in there, but the electrons have a very small mass, and so the mass of the electrons doesn't really affect that number very much. I mean, we said an electron is 1/2000th of a proton. Okay, so if I have an atomic mass number of 1, then adding the electron to it makes a difference of 1.0001. Okay, I mean, so it's not much difference. Okay, so we just kind of ignore the electron when we're talking about the atomic mass number. Okay, so looking at carbon, I see 12.001. Let's talk about what that means. Carbon can form in multiple ways. Okay, and the different ways that carbon can form is called isotopes. And what an isotope is different configurations of the same element. So different configurations of the same element would just have different neutrons, different number of neutrons. So they have the same number of what? Protons, the same number of protons, but a different number of neutrons. Okay, and the way that we write an isotope, okay, is we just write out the element name, and then we write out the number behind a dash. Okay, so I could have boron 10, or I could have boron 11. Okay, whatever number comes after the dash, that's the atomic mass number. Okay, so boron 10 would be boron with an atomic mass of 10. Boron 11 would be boron with an atomic mass of 11. Number of neutrons. Okay, so looking up at these guys, I see an atomic mass of 12.011. So that's going to tell me a little bit about the isotopes. I could have carbon with an isotope of 12. I could have carbon with an isotope of 13. Okay, I mean I could have one or the other. That's because 12.011 is between 12 and 13. And I could have 11, I could have 14, but these are going to be the most common. Okay, that makes sense so far? The most common isotope is going to be what this is closest to. So 12.011, is that going to be closest to 12 or 13? Oh. Sorry. Okay, so 12.011 could be 12 or it could be 13. 12.011, though, is closest to 12. So 12 is the most common isotope of carbon. Okay. Looking up at helium. All right, let's pick another one. Oxygen. Okay, oxygen. It could be 15, could be 16, could be 17, could be 14. Okay, but the most common is going to be 16. Why? Because this is the closest. Okay, to figure out which one it is, guys, just use your rounding rules. Okay, so if it would round up to 16, it's 16. If it would round down to 15, it's 15. Okay, so what we're going to be doing today is we're going to figure out for each element, we're going to learn how to figure out the number of protons in it, the number of neutrons in it, and the number of electrons in it. And this is real simple. The number of protons is equal to the atomic number. So the number of protons is going to be this number here, which is 8. Okay? The number of electrons is, for now, the same as the number of protons. Okay? So this is also 8. Okay? And then for the number of neutrons, you're going to take the most common one. Okay? So in other words, round this number. So 16. Subtract the number of protons, and you get the number of neutrons. Okay, sometimes they'll all three be the same, but they won't always. Okay, let's do this for carbon up here. Okay, 12 is the most common, so my protons here are going to be 6. Okay, the electrons, 6, and then the neutrons are going to be 12 minus 6, or 6. Easy? Okay, let me give you all a few to try. Mm-hmm. I'm going to round a little bit. Fluorine. It's Friday. All right, guys, try those 3. It does.
Question.
Mm-hmm.
Okay, so protons, neutrons, and electrons. Okay, well, so that number up here is the number of protons.
And the electrons.
And the electrons.
Mm-hmm.
So, and these two are not the same one.
For now. And that'll
But
change
as
tomorrow.
of right now.
Yes,
Oh.
right.
And so you say when you round it, so say that's 18, so you say 18 minus 9?
18. What is 18.9 round to?
19.
19.
What's the number for beryllium? Can you subtract the top number?
Now you should know the number for beryllium. We've had an elements quiz on beryllium. You know where it is?
I see, but I can't see beryllium.
It's 4.
Like that? You just say times the top number.
Alright, somebody want to come get some answers for me up here? You do the first one.
Me?
Probably you do the second one for me.
Yeah.
You do the third one. Okay. And y'all can pick whatever color you like.
Oh, yeah, didn't know that.
Spider-Man gonna be Spider-Man. Look at the first two guys. Fluorine. We have 9 protons, 9 electrons. That's by the top right number. Okay, 18. You can go ahead. 18 is going to round to 19 because it's 18.9. So 19 minus 9 is 10, and so we should have 9, 10, and 9. Correct.
Is it further? Is the
Yeah. Okay, in the middle one, those are correct as well. She showed great work. So and then the last one, since beryllium has an atomic number of 4, then the protons and the electrons are 4. And since I set the atomic mass to be 10, then it would be 10 minus 4 or 6. All right, any questions? Easy?
Easy breezy.